There's a planet out there that scored higher than Earth on our own Earth likeness test, and we can never reach it. On January 6, 2015, NASA confirmed a world that shouldn't exist. Out of 5,500 planets we've discovered, not one has matched Earth, until Kepler 442b. This planet didn't just match Earth, it beat Earth at being Earth-like. 3 specific things make this planet more like home than anything else in the universe. And when you understand what they are, you'll realize we've been looking for Earth's twin in all the wrong places. The first thing is a number so impossible that scientists checked it 3 times before believing it. They call it the Earth Similarity Index, a mathematical test that compresses an entire planet's identity into one score. Earth itself scores 0.829. Mars scores 0.73, Venus scores below 0.4. Then they measured Kepler 442b. It scored 0.836, higher than Earth itself. Think about that. We built a mathematical test to find Earth's twin, and a planet 1,196 light years away scored better than the planet we're standing on. It's like entering a look-alike contest for yourself and coming in second place. The universe played a cosmic joke, and we're the punchline. But numbers hide stories, and this number tells us something profound. Kepler 442b is 30% larger than Earth. Not too big that gravity crushes you, not too small that atmosphere escapes into space. It sits at exactly the right distance from its star to receive 81% of the energy Earth gets from the sun. Mars only gets 43%. That's why it's a frozen desert. Venus gets 191%. That's why its surface melts lead. Kepler 442b lives in that narrow corridor where water doesn't freeze or boil. It just flows. Picture a dartboard the size of a solar system. The bullseye is the zone where life can exist. Not too hot, not too cold. Most planets miss the board entirely. Some hit the outer rings. Kepler 442b landed so close to center that it beat Earth's own position. Every measurement lined up like cosmic dice, rolling perfect sixes, over and over, defying probability. Scientists were so skeptical, they created a second test called Cepheid, a deeper evaluation of actual habitability, not just Earth-likeness. When they ran every known exoplanet through both tests, Kepler 442b ranked in the top 3 for habitability and scored highest for Earth similarity. 2 completely different mathematical frameworks built by different teams, pointing at the same distant world saying, "This is the one." The discovery came from the Kepler Space Telescope, a machine that was dying when it found this world. By 2013, Kepler had lost 2 of its reaction wheels, crippled and drifting. NASA engineers performed miracles to keep it operational, using solar pressure like a sail to maintain stability. This broken telescope, held together by ingenuity and stubbornness, managed to spot a planet more Earth-like than Earth. It's like a dying detective solving their greatest case with their last breath. But even perfect measurements mean nothing if your star is trying to kill you. And that brings us to the second thing that makes Kepler 442b special. It orbits a better star than our sun. Our sun is like a brilliant performer that burns out young. It's a G-type star that stays stable for 10 billion years before expanding and dying. Kepler 442b orbits a K-type star, cooler, quieter, and destined to shine steadily for 30 billion years. That's 3 times longer than our sun, 3 times more opportunity for life to evolve from microbes to consciousness. On Earth, it took 2 billion years just for cells to develop nuclei, another 2 billion to go from single cells to complex organisms. Kepler 442b has triple our time budget to write its story. Think about what life could become with 30 billion years. Earth produced intelligence in 4 billion. What happens with 30 billion? Kepler 442 star is just getting started. When our sun expands and destroys Earth in 5 billion years, Kepler 442b will still have 25 billion years ahead of it. It's the difference between a mayfly and a redwood tree. The famous potentially habitable worlds everyone talks about. Proxima Centauri b, the TRAPPIST-1 system, they orbit M-dwarf stars. M-dwarfs are the violent teenagers of the cosmos, throwing super flares like tantrums, sometimes daily. Each flare is a radiation bomb that can strip away atmosphere and sterilize any surface life. Imagine getting hit by a Chernobyl-level event every Tuesday. That's existence around an M-dwarf. Kepler 442's K-type star is the responsible adult. When NASA's Chandra X-ray Observatory measured its radiation output, they found something remarkable, even accounting for the star's younger, more active past. The total lifetime radiation dose matches what Earth received while life was evolving. The star isn't just calm, it's protective. Like a parent that knows exactly how much challenge strengthens a child without breaking them. There's another advantage to K-type stars that astronomers call the Goldilocks stars. They emit light at wavelengths perfect for photosynthesis. If plant life exists on Kepler 442b, it would thrive under that orange-tinted light. The star's spectrum peaks exactly where chlorophyll absorbs energy most efficiently. It's as if K-type stars were designed to grow gardens across the cosmos. But even the perfect star can't save a planet with the wrong orbit. And this is the third thing that makes Kepler 442b extraordinary. It dances instead of stares. Kepler 442b escaped this nightmare by just 0.047 astronomical units. But rotation means nothing if your orbit is chaos. Mars has an elliptical orbit with an eccentricity of 0.093, swinging between extremes that create planet-wide dust storms and temperature swings that would collapse any civilization. Earth's orbit is nearly circular, with an eccentricity of just 0.017. That tiny number is why we have stable seasons instead of apocalyptic extremes.
A 2023 climate model from the University of Hawaii simulated Kepler 442b with various atmospheric compositions. Even with a thin atmosphere like Mars, the planet could maintain liquid water near its equator. With an Earth-like atmosphere, the entire planet could support vast oceans. We found Earth's twin, and it's forever unreachable. It's like discovering you have a perfect genetic match for a life-saving organ donation, but they live in another dimension. The James Webb Space Telescope could analyze its atmosphere, search for oxygen or methane, biosignatures that would confirm life. One detection would change everything. But as of today, no one has pointed humanity's greatest telescope at humanity's greatest candidate. We're too busy studying closer. More famous worlds that score lower on every test we've created. The three things that make Kepler 442b special are the same three things that made you possible. We found them written into a world we'll never touch, and somehow that's both heartbreaking and beautiful. Sometimes the greatest discoveries aren't about what's out there. They're about understanding what's right here. Maybe one day, thousands of years from now, our descendants will develop technology that makes 1,196 light years feel like a morning commute. Maybe they'll stand on Kepler 442b's surface and look back at Earth, if it still exists, understanding finally what we could only see in numbers. Or maybe Kepler 442b will remain forever what it is today, a perfect reminder that the universe creates masterpieces we're meant to admire, not possess. If this changed how you see Earth, subscribe for more stories about our cosmic neighborhood. Here's a thought that keeps me up at night. If Kepler 442b has intelligent life, they might be looking back at us right now, seeing Earth score lower than their world on their own tests. What would you want them to know about Earth that numbers can't capture? Drop your message to them below.